Hi guys, it's Mrs. B, and we're going to go ahead and start learning Chapter 2, which is all around solving equations. So let's go ahead and get started. This is going to be Lesson A, 2.1 through 2.3. In the first part of Chapter 2, we talk about the properties in algebra, which are the commutative property of addition and multiplication, the associative property of addition and multiplication, the identities for addition and multiplication, and the distributive property. In the commutative property, we're talking about the order not mattering. So the commutative property states that the order in which you add or multiply does not matter. The answer is going to be the same. So for example, A plus B is the same as B plus A for addition, or A times B is the same as B times A in multiplication. In the associative property, we're talking about the grouping. And the grouping doesn't matter in addition and multiplication. So for example, A plus B plus C, if we do A plus B first, we're going to get the same answer as if we do B plus C first. Same goes for multiplication, A times B times C. If we multiply A times B first, we're going to get the same answer as if we multiply B times C first. The identity properties for addition and multiplication are the following. A plus 0 equals A. That's for addition. And A times 1 equals A for multiplication. These are identity properties because when you add 0 to any number, you get the number right back. So you get his identity back. You multiply any number by 1, you get its identity back. So we like to call 0 the additive identity. And we like to call 1 the multiplicative identity. Yes, his name is 0, but he's also known as the additive identity. Yes, his name is 1, but he's also known as the multiplicative identity. So now we're going to talk about the distributive property, such a super important property. The distributive property is for when you have multiplication over a sum or over a difference. So notice in this particular case, we're multiplying A to the sum B plus C, or we're multiplying A to the difference of B minus C. In many cases, when we have numerical expressions like 3 times 4 plus 1, when we have numerical expressions, we just go ahead and we add inside the parentheses first and then multiply it by 3. Well, that's all great, except we don't always work with numerical expressions. Sometimes we're working with variable expressions. So let's take a look at this variable expression, 3 times x plus 2. Well, I can't add x and 2. No, it's not 2x, that's 2 times x. That's not x plus 2. So let's erase that. So we're back. Can't add x and 2. So how do we make this expression simpler? Well, we will apply the distributive property. The distributive property says that A multiplied to B plus C is the same as A times B plus A times C. And A multiplied to B minus C is the same as A times B minus A times C. So in this problem, or this expression, it would simplify to the following. It would simplify to 3 times x plus 3 times 2, or 3x plus 6. We want to be really careful when we have distributive property problems and negatives. So I'll give you another example. Let's take a look at negative 5 multiplying to x minus 3. So I like to draw little arrows to show that -5 is multiplying to x and -5 is multiplying to 3. I'm sorry, to -3. So -5 multiplied to x is going to be a -5x. But right here, this is the sign of the 3. Subtraction of 3, which is the same as adding a -3. The sign in front of the number belongs to the number. So when -5 jumps over here and hits the multiplication of -3, it's actually going to become plus 15. It becomes a plus 15 because -5 times -3 is a positive 15. Sometimes you'll see problems like this one. Negative, parentheses, x, let's say, plus 2. In this particular situation, you're still distributing, but you're simply distributing the negative sign into the parentheses. So, or an invisible -1. Some people like to say there's like an invisible -1 there. So, we go ahead and distribute the negative to the x and the negative to the positive 2. Negative x minus 2. And it's a minus 2 because negative times positive makes negative. So that's a little bit about the distributive property, and it's a really important property when we start to simplify expressions. So before we simplify expressions, we're going to talk about some quick vocab when it comes to expressions. So here are the vocabs. The words are terms, like terms. Oh, where's my pointer? Here we go. Terms, like terms, coefficient of a term, and constant terms. Terms are the parts of the expression. So here's a really big expression. It is algebraic because there are variables in it. I'm sorry, it's variable. Also algebraic. Variable because it has variables in it. And there are 1, 2, 3, 4, 5, and 6 terms. So the terms are the parts of the expression. And you can tell that the terms are kind of like separated by the plus and the minus signs. The terms in this expression are, ready, 2y, 3x, -y, positive 5, positive 2x, and -4. Those are the terms. Now the like terms are the terms that have variables that are in common. So for example, 2y and -y are like terms. Positive 3x and positive 2x are also like terms. Positive 5 and -4 are also like terms with each other. They don't have to come in pairs. There could be 3 of the same or 4 of the same, and not everybody has to have a like term. So 2y and -y are like terms with each other. 3x and 2x are like terms with each other. Positive 5 and -4 are like terms with each other. Now the coefficients of a term are the numbers in front of the variables. So, for example, 2 is a coefficient, 3 is a coefficient, -1, in this case right here, is a coefficient, and 2, again, is a coefficient. So we have 1, 2, 3, 1, 2, 3, 4 coefficients, 1 for each variable. Positive 2, positive 3, -1, and positive 2. Constant terms are just plain numbers. So for example, positive 5 is a constant term and -4 is a constant term because they're not attached to variables, so they're constant. So we're going to go ahead and take a look at this example. We're going to identify the terms, the like terms, the coefficients, and the constant terms for this expression right here. Remember, the terms are the parts of the expression. So the terms are y, 8, negative 5y, and negative 3. Y, 8, and I'm going to separate them with a comma, negative 5y, and negative 3. My like terms, well, y and negative 5y are like terms. And also, I'm going to go ahead and say, let me put a little semicolon here, 8 and negative 3 are also like terms because they're both constants. Coefficients, remember coefficients are numbers in front of variables. So the number in front of y is an invisible 1. And the number in front of negative 5y is negative 5. So my coefficients are 1 and negative 5. And my constants, numbers without variables, are positive 8 and negative 3. So we've got all the vocab down. Now let's start simplifying. To simplify an expression, we have to distribute first. So if there's any kind of distributive property in the problem, we need to take care of that first. Then what we're going to do is combine any like terms by adding or subtracting them together. Be very careful because you can only add and subtract like terms. If they're not like terms, you can't add them together. Remember when we talked about x plus 2 and how it's not equal to 2x? Well, 2x is a multiplication problem. So an addition problem doesn't magically become a multiplication problem. Also, these guys are not like terms. X is an x and 2 is a constant. So this would be as simple as it can get. Can't add them together. Okay, we have some example problems here. I'm going to go ahead and start with one that doesn't have distributive property. If you look at all of these questions, there are only 2 in here that don't have the distributive property, which they're 19 and 20. So I'm going to go ahead and try 19. I'm sorry, I'm not trying 19. I'm trying number 20. There's no distributive property, so I don't have to take care of that first. What I do want to go ahead and do is combine my like terms. There are 3 terms. One. Oh, come on, pointer. You can do it. I believe in you. 1, 2, 3 terms. And they're all like terms because they all have c squares. So let's go ahead and combine them. 9c squares take away 4c squares. That's 5c squares. Add that to 2c squares. That's equal to 7 of them. 7c squares. You're done. A 3-term expression simplified down to a single term. That's not always going to happen, guys. It just happened this time. Let's try another one. All right, next I'd like to try number, let's see, 24. So negative 2 multiplied to 2m minus 1 plus 4m. This one does have the distributive property. I see it right here. So that's what I want to take care of first. Always, always take care of your distribution first. Negative 2 times 2m, that's negative 4m. And negative 2 multiplied to minus 1, we'll change that minus into an addition of 2. And then bring down your plus 4m, because he wasn't distributing, so he was just waiting very patiently. Now I do have like terms, because we're always going to first do the distributive property if the problem has it. And then we're going to check for like terms if the problem has it, which it does. It has one here and one here. Notice how I also circled the sign in front of the number because it belongs to that number. So we are going to combine a negative 4 and a positive 4 to get 0 m's plus 2, or simply 2. Because 0m is straight up 0. Let's try another one. All right, this time I chose number 27. Negative w plus 4 minus parentheses 3w minus 13. This does have a distributive property. It's right here. We're distributing this minus sign into this parentheses. So it'll look a little something like this. Negative w plus 4 minus 3w plus 13, because a minus with a minus makes a plus. We're going to combine some like terms. I've got a like term here with a like term here. Combine those together to make a negative 4w, because that's an invisible negative 1. Combine this guy with this guy to make a plus 17. And we cannot get any simpler than that, because negative 4w and positive 17 are not like terms. All right, so to sum it all up, what we've covered in this video, there it is, guys, he's back. We covered the properties, which were the commutative property, order doesn't matter, associative property, grouping can change in plus and time. Remember, these properties are just for adding and multiplying, okay? Commutative property, order doesn't matter for adding and multiplying. Look at that. Isn't that cool? Associative property, grouping doesn't matter for adding and multiplying. Identity, anything plus 0 is itself. Anything times 1 is itself. Distributive property, that's when we took a number and multiplied it into an addition problem or into a subtraction problem by doing those little loops. We talked about terms, like terms, coefficients, and constants. And we practiced simplifying an expression, which are the steps are to distribute first and then to combine like terms. If the problem doesn't have the distributive property, you go straight into checking for like terms. That is Chapter 2, Lesson A, Whisk. I am Mrs. Basilis, and yeah, we're done. Bye-bye, kids.